Okay. Hey, guys. We'll be getting started in a few minutes. Sorry for the delay. I was on the wrong channel. I'll be right back. I'll be right back. But if you have questions, drop them in Slack. I'll answer them when I get back. All right. How's it going, everybody? Cool. A bunch of you showed up in the meantime. Let's see, who do we have? Danielle and Deandra helped me with some tech support stuff, so thank you for that. Luke's here. Deandra's here. Taylor's here. I'm up now. Awesome. Brad. Hello, Brad. Hi, Randy. Hi, Laura. Hi, Leah. Sana. You got me on the big screen. Hi. Who else is in there with you, Sana? Is Leah with you today? Austin. Hi, Austin. And Robert. It's good to see everybody. What's going on? Hey, Farid. Good to see you. Farid, were you able to get up the link from Tuesday? Hey, Giovanni. Hey, Giovanni, aren't you in the wrong class? Giovanni, I think you're in the wrong class. I mean, you're welcome to hang out. But stat doesn't start till 12:30. So if you want to get in on the oh, hey, Leah. Yeah, there. Giovanni, I'm gonna post that to a different feed, so you're welcome to hang out and learn about regression. Okay, cool. But I don't know if you can hear me. If you're logged in or not. Huh. Very possible. It's all right. I mean, you can stick around. Can I resend the YouTube link, please? It's posted above. It's right up here. So if you scroll up in general here, you guys can see you now. See. Hi, Mom. I'm on TV. Right. But if you go up top, the regression table interpretation link up there is where you want it. So just scroll up there. Cool. Okay. See you in a bit, Giovanni. So now we can you can see how long the lag takes, right? It's right there for you. Willie B is typing. Hi, Willie B. Let me know if that works, Laura, if you can scroll up and click it. More caffeine, more caffeine. Cool. Glad to hear it. What's been going on with you guys today so far? It's 10:55. You have indeed arrived. And in the meantime, since then, or since this morning, I was on Twitter, which I don't do a lot of, but every once in a while I go on Twitter, trying to explain Superman to people. There's a new movie out apparently, which I haven't seen yet, but people were being dumb on the internet about Superman, so I was jumping in to explain Superman so that, I don't know. I don't understand why they keep making movies where Superman punches stuff. I think he's a much more interesting character in his, I don't know, more, whatever. His more interpersonal, how do you be like from another planet and try to fit in? I don't know. It seems more interesting to me. In any case, they seem to want him to punch stuff, so he's punching stuff in the new one. I'll probably see it and like it because, I don't know, I like movies. I like every movie, but yeah, I personally growing up was more of a Superman fan than a Batman fan. So I felt some personal responsibility to let people know what's going on the internet. But yeah, what are you all up to? I went to the gym yesterday. I don't know. Did I tell you guys I'm a rock climber? I rock climb these days and had a good day. Were they saying he's too overpowered? Yeah. And also, like, what's the deal with? Is he like a space Jesus? I believe was the phrase that was used. Just that. Yeah. Just like, what's the interesting thing about, you got somebody who's like invincible. Like, well, that's why I think it's much more interesting if there's some conflict. Luke, you asked me via direct message something, if that's okay. If I say it to everybody, because your question was, can you watch this video later? Yes, indeed, you can watch this video later. But if you're watching it later, you're not going to be able to participate in the Q&A, right? So if you have questions, you won't be able to see that stuff. Wonder Woman all the way. Yeah, I'm right there with you, Deandra. I'm looking forward to that movie. And she's awesome. Wonder Woman's awesome. The backstory there is really cool too, of like her parents not want, or whatever, her mother not wanting her to participate in like out society. Do I go on Thursdays with Outdoor Adventures? No, I've seen them there sometimes. And I'm always happy to see GGC represented there. But no, I usually go, I don't teach it on Mondays and Wednesdays these days. So I usually try to go pretty early when it's quiet. And there aren't a lot of people there. My daughter's on the climbing team. And so she goes, it's Tuesday and Friday nights. And so I'm sometimes there on Tuesday and Friday nights. She used to be there Tuesday, Thursday nights when she was on the other team. But yeah, no, usually I go, and I got my wife into climbing. So we usually try to go when it's quiet. I mostly boulder because for me, I have a bad shoulder. So a lot of it is just trying to keep my shoulder intact. But I finally moved up a grade to V4, V5, which is climbing jargon for kind of hard climbs. And so it's been about a year since I moved up a grade. And so to move up again, hey, Katie, to move up again felt pretty good. You notice when there are other people at the gym who like before didn't talk to you, who now are like, hey, yeah, that's a good climb. You should try that, or whatever. Like they talk to you now. And so it's always nice to receive a little bit of a positive reinforcement from total strangers who are better, or they look like big, strong people. So that's always satisfying. Hey, I'm on TV. Cool. That's awesome. Thank you. Thanks for sending that. Someday you guys will have to have big watching parties. Oh, this is the wrong. I didn't finish putting together the outline for this. Hey, this stuff is wrong. We did all this stuff. This is where we are today. So there now that's accurate. And also problem set 8 was already due. You guys turned that all in already? But yeah, it's very satisfying. There's this one crazy climb where you have to do what's called campusing, which is to say you're hanging from your arms and you just have to like pull up really hard and then reach up really high. It's like you basically have to jump with your arms like 3 or 4 feet, 3.5 feet probably. And I saw some guy like trying it, and it's always very entertaining. And so I said like, I'm sorry, I'll participate in the entertainment. Hey Samantha, like, because it's kind of like, if you're gonna embarrass yourself, I'll embarrass myself. Well, I'll embarrass ourselves. And then like I did it, and I was like, whoa, I just did that, and it was kind of satisfying. Although I felt bad, I was trying to like, I was intending to make the guy feel better about the fact that he didn't do it, but instead I unintentionally showed him up, so I felt a little bad about that. But I didn't feel as bad about that as I did feel good about the fact that like, whoa, I just did something crazy. That was awesome. So that was my experience of it. Makes sense. Anyway. Ooh, 11:26 in the library, people. So if you're on campus and you want to hustle over there, class is about to start, but you know how the beginning of class goes sometimes. How many people we have on? We got 113 members, which is multiple classes. We got 15 people on Slack. So if you're watching this, and you're not, thanks, Yandra. If you're watching this, hey, Mohammed, and you're not on Slack, you should go to econ.dr.slack.com. Obviously, if you're in my class, I think I'm broadcasting this publicly because I don't know how the internet works. So it's possible that you're total strangers. You don't think you're in the right room, Brad. Is your exam still Tuesday? Yes, Robert, your exam is still Tuesday. Someone else is talking. I don't hear anybody else. Let me see if I can. Yeah, maybe. Somebody else is talking. I'm very confused, Brad. Did you click on the link above? Or in the email that I sent you? Hey, Joshua. Yeah, Brad, I want to help you deal with that, but also I want to start class. So in any case, as far as I know, just to give you guys updates while I'm waiting to hear back from Brad as to whether or not he's actually able to see this. Someone else is talking. I don't think I have any other speakers going on. I'm very confused by this. Gotta have my pops. Like corn pops? I mean, I'm very confused. Hi, Cooper. You're very confusing. Sophia's here. Hi, Sophia. I see you typing. The building is closed till Sunday, is what I heard. Hi, Sophia. Welcome. Hey, Juan. Jerron's here. Hi. The building is closed. Okay. Other stuff. Any other questions about what's going on? I tried to get back to as many people as I could about the issues with. Several people are typing. The issues with the projects. I know I got in touch with, I think, everybody who had gotten in touch with me. I'm a little scared. What I'm going to delete? Oh, Robert, you asked me that question. What if your registration ticket is Tuesday at 11? I really don't know what to tell you, Robert. I don't know. You might as well. You can kick it out to everybody. I'm glad you missed it, Willie. You can kick it out to the group, maybe. Robert is in a situation where he has a registration ticket for Tuesday at 11, and he's got an exam in my class, this class. I would say you probably can wait till you're done with the exam to register. Or if you think you have enough time to register quick, you know what you want to register for, like quick register and then come to class. Yeah. You let me know what you think. I don't know, or let each other know. Let Robert know what you all think. It's a tough call. I don't know. What do you guys think is fair? Do you think I should let Robert come in and late because he has to register and then take the extra time at the end of class? If that seems like a consensus willingness to do that, then I could, however many minutes you think it takes you to register, 5-10 minutes, I can extend your time only for 5 to 10 minutes at the end. If everybody else thinks that's fair, then that's fine with me. Other stuff? Okay. Yeah, he can start anytime after 11, Sana, but the issue there is he's worried that he won't be able to register for classes that he wants. So I don't know. We are a community. If you guys think that it's okay for, the one person who has a registration ticket at 11 to have an extra 5 minutes at the end of the class, that's fine with me. If not, I mean, I'll think more on it, but I'd like the class's input on that if people are willing. All right, we don't have a ton of stuff to get to today because I don't want to take up too much time before the exam. So my plan is to go over Excel output and then to do a practice problem from problem set 9. Have your class numbers ready to type in right at 11. It should only take you 2 minutes. Move the exam to Thursday. Mohammed, you're a funny guy. 5 minutes is fair. Okay. Yeah. Okay. If everybody thinks giving you 5 minutes extra, yeah, come in. That sounds like a good plan, Robert. Register for your classes. There are computers right there, like in the A middle section. So go register on those computers. Get lined up as soon as it ticks over. Register. Come to class like right next door, and then take the exam and celebrate 2 successes in less than an hour. Right. That's the plan. By the way, if you don't feel comfortable expressing a disagreement with that, you can chime in on my via direct message, and I can see your direct message, and that'll tell me. You can tell me a direct message so that you don't have to like state in front of the class, yeah, Robert should not, he should not get that extra time. Like, you can tell me your honest feelings, so I'll just you don't have to tell the whole class. Okay. In any case, last class where we left off. Now that we're like 6 minutes in. And I have your attendance, by the way. I'm taking attendance based on your messages on Slack. So I can go in and check to see if you were on Slack. If you were logged in, I can check your login time and stuff. So that works right as well. Now, we're not moving the exam, especially because today, like, we're going to have a short day because I don't want to talk about more stuff so that we have to put it on the exam. Today, I want to talk about where we left off last class, which was simple linear regression, using Excel to do our regression work for us. We're going to get into multiple regression. So I'll talk about multiple regression a little bit today, maybe. But where we're going to start is just learning how to use Excel to run a regression, because it's useful. We are broadcasting, Brad. Yes. Yes, Brad. I'm just going to give Brad the link quick, if that's okay with everybody. Meanwhile, I'm putting my data into Excel. So here's the link, actually, pinned to general. There we go. That should give Brad the link. Cool. Does the broadcast work on smartphones? I'm trying to connect now. Yeah, it's just a YouTube video. So can we extend problem set 9 one day? I'm going to say no, but I'm going to remind you of my grading policy, which is that there's a due date. And then if I haven't gotten to grade anything yet before you turn yours in, it gets full credit because that's on me, not on you. So as long as you get in. Yeah, that's right, Lubov. Welcome. It's good to see you. Oh, by the way, this is my just to show you what I'd like to toss around when I'm bored or whatever, when I'm thinking. This is a little owl beanbag. It's very cute. Occupies my desk. Anyway, yeah, you ask questions on here, Lubov. Oh, hi, Jean. Welcome. Cool. Hey, Tom. I'm totally scattered today. We are broadcasting. We're going to talk about regression. And we're going to start by working with this data here. So starting from scratch, if you have Excel and you have access to it, I'm not going to extend it for a day, but like I said, John, turn it in a day late, and I probably won't have graded it yet, and it's fine. Laura, if YouTube froze, reload it. So if you have Excel, when you click on data, you probably don't see this data analysis thing here. You can see funcres.xlam is the file that creates this data analysis thing. But if you have just a vanilla copy, I guess is what you would call it, of Excel, you have all these sections you get to outline, and then it's done. Now this data analysis is really handy. It's a tool pack, and you can see that it has some stuff in it, some things that you might recognize now that you wouldn't have recognized before. Correlation, covariance, histogram, regression, which we've been talking about, right? Sampling, t-test, paired two sample for means, Two sample assuming equal variances, two sample assuming unequal variances. Hey, there's F test two sample for variances. So there's a bunch of stuff in here that Excel knows how to do that we've talked about. So now you can use Excel to do it. The tricky thing, or one tricky thing about this is that this tool pack was made in like, I don't know, maybe it tells us like the copyright date on this tool pack is like, I don't know, 2001, 1998. It's been a while since they've updated this. So it's a little bit clunky. I don't know. I'd be interested someday to study the history of the tool pack because it's useful, but it definitely feels a little clunky. But for running regression, it's the best way to do it. There's actually another way using what's called the linest command or formula, but that involves array functions, and that's a whole other mess we don't want to get into. So we're going to use the data analysis tool pack to do that. By the way, if you have an Apple computer, you're going to have to use something different. It's called stat plus LE. Here, let me see. I don't want to do that. I want to go like this. Just so y'all know, stat plus LE is the name of the. So I'll write these things down so you guys can write them down too. Hey, oh, that's the background color's the problem. So for most versions of Excel, we're talking about the data analysis tool pack. And so if you can't find it, you're going to want to Google this. I have another video. I have a video that shows you how to do this. I mean, in addition to the one that we are recording while we speak. But if you're using Apple computer, a Mac or whatever, I don't even know what to call them these days, AirBook, Stat Plus, I think LE is like the free version. And it basically, for Office stopped supporting, Microsoft stopped supporting the data analysis tool pack. And so some engineers there went off and formed a third-party company just to keep providing that service. So that's where you'll find the things that I'm about to do. Cool. I mean, the overarching thing is you shouldn't be using an Apple because like it's a ridiculous computer for ridiculous people. But if you insist, yeah, it's kind of like a add-on. It's a different piece of software. Google it, right? So that's what you really want to do. You just want to Google it. If you Google stat plus LE, you'll see what it is. In any case, if you have a Windows machine, which you almost certainly will in most of your offices that you work at, what you want to do is, here, I can show you how I did that. Go to the File menu in your Excel, and then you can see a whole list of options here. You probably have never gone farther down than like Print before. Go to Options. And when you click Options, it gives you lots of Excel options. If you've never been here before, this is pretty handy. Being able to change the font size and stuff can be useful. Changing autocorrect options is useful. One thing I do is I have math autocorrect replacing text as I type. And so this shows you how you can automatically insert things like betas in Excel. In any case, that's in the weeds a little bit. What we actually want here, hey, yeah, Apple's the best, yeah. Yeah, anyway. What you want is to click down here on add-ins in the Excel options, not the Trust Center, the add-ins. And then down here, you'll see Manage Excel add-ins. Here's a list of all the things you can have here, right? So there's a PDF maker that I have, Power Pivot. I guess I have Power Pivot installed. I think Power Pivot's always, I don't know if it's always installed or not. But the one we want is in this Manage Excel add-ins. We click Go. And you can see, at least I have 4 options. I think these are the 4 that come kind of with the vanilla install of Student and Home or whatever, maybe even Professional. I don't remember which version of Office I have. But Analysis Tool Pack, the first one you can see, provides data analysis tools for statistical and engineering analysis. You just want to make sure this checkbox is checked. Okay, and then we click OK. And if you do that, you should see on your Data tab, right? So if you're here, you won't see anything happen. But if you click over on the Data tab, you should see this little data analysis thing pop up. And data analysis makes it possible to do regression pretty quickly. Now, I mean, when you're good with Excel, it's pretty straightforward to do regression pretty quickly, right? So if I just want to show you like how quickly can I come up with an estimate of beta, it doesn't take me very long, or an estimate of B. It doesn't take me very long to do it by hand. And that's partly because I'm pretty fast with this stuff. So these are xi minus x bar, y minus y bar. Multiply these together. Oh. And we already did this, right? Did I do that right? I didn't do that right. That's how you do that right. And then square these. And so our estimate of beta is that. And then our estimate of alpha is going to be y bar minus b times x bar. And so when you're good with Excel and you can move around pretty quickly, it doesn't take that long to do it by hand, especially if you only have 5 data points. But the problem is that's just A and B. There's a bunch of other stuff we want. It's also kind of messy. And so if we had to get the SSE and the SST and the SSR and the R squared, it would take a long time. And it would be very tedious. We'd be doing the same calculations again. That said, being able to do what I just did as quickly as I did, like, it will help you literally every day at your job to be able to do that sort of thing. And so I would recommend, like, now that you know how to do this stuff in Excel, and you already have problem set 9, like working on problem set 9 in Excel just to practice doing calculations in Excel is a really good way to learn how to use Excel. And it's hard to find good ways to learn how to use Excel. A lot of people will just open it and like, okay, what now? And I would recommend, like, you have problems that you know what the solutions are and you know the process. And you can see that when I use Excel, mostly what I'm doing, if you look at what I'm showing you up here is this formula bar, I'm just manipulating that formula bar, right? I mean, I'm just using subtraction and multiplication, raising things to powers, using sums, subtraction and multiplication and division. And so just using Excel as a powerful calculator quickly is a really good habit to get into. That said, that only will work in this case for simple regression. When we want to get to multiple regression, we would have to use some vector mathematics. And Excel's okay at that. It has a formula called sum product, which you can use for vectors. You have some, so that's like the dot product of 2 vectors. But we're going to try to steer clear of using sum product too much. It comes up every now and again. I just don't want to get into the vector math of it in this class. It's not, we haven't had a linear algebra class. So instead, what we're going to do is we're going to use the data analysis tool pack. So if we click data analysis, it'll give us a bunch of options. Regression is the one we want for now. We click OK. Our input Y range is our Y variables all the way down as far as we want it to go. These are Y bar and X bar. So actually, let me delete those before I accidentally use them ever again. And so our Y variable is this thing right here. And you'll notice that in here, I included this change in sales Y variable. I'm also going to include that in my X variable. And you can see there are some check boxes here. Actually, we can just stop for a second so we can look at this. The top section here asks us for our input. We have a Y range. We have an X range. And then there are some check boxes. We can force the constant to be 0. That's essentially saying we want A to equal 0. So we just want a line that is forced to start at the origin, and then we just want the slope estimate. We could do that. We shouldn't. There are some cases where you want to force that, but very rare. We want to check this labels because I included the labels in my you can see when I click on these, we included the labels in here. You also can change the confidence level. It'll give us some confidence intervals, and you can set a custom confidence level if you want a particular confidence interval. Output options. This one here, we want to name it something useful. One of the big disadvantages of using Excel, I don't know why they do this, but when they spit out the regression data, they don't tell you in the regression output what the dependent variable was, what Y was. So if you don't make a note here, so let's say you're running a bunch of regressions and there are a bunch of different things, like let's say you care about somebody's income, but you also care about their general reported life satisfaction, and you care about their their savings for retirement, and you're running a bunch of regressions where you have 3 different Ys because you're curious about 3 different things, and you have a bunch of the same models with X's. So you want to know how somebody's education and their age and their experience affects their income, but you also want to know how that stuff affects their savings for retirement. Well, when you run those 2 regressions, the X's will be the same, but the estimates will be different, but you won't know which is which unless you label it somehow. And that's where this comes in handy. Sales equals % options will tell me what my model is, right? So I always try to, my notation, and this is just a personal thing, I always have my left-hand side variable, then an equal sign, and then I just list my right-hand side variables so that I know which model is coming from here. There's some other stuff down here that we'll deal with later. We'll deal with residual plots later, but for now we can just click OK. And if we do that very quickly, it gives us our output, which is awesome. That's great. We want this output. It's handy. And it should look familiar because we've seen it before. I think we looked at it last class, but we also have played with it a little bit. And what I'm going to do now is I'm going to copy this into Paint so that we can talk about it piece by piece. So print screen. All right. Sorry to duck down there so I can see my very small keyboard keys. I don't use print screen very much. And then if I paste that here, we should be able to see our output. Cool. Look at that in Paint. And now I can draw on it. Very satisfying. Okay, let's switch back to brushes. And move this back over here. There we go. Cool. Okay, so what to think of this stuff? Well, it's got a few different parts. And so let's kind of take it one section at a time. Here we have, let me actually, over here, let me go back to the original data so you can see the original data this was drawn from. There are three major sections to this. The first part is called regression statistics. The second part is called ANOVA. And the third part, I just call part 3 because it doesn't have a name. And so just trying to digest this, when I first get here, usually the things I look at, just so you guys know what are really important before I explain what they all are, or before we go step by step. The first thing I look at is this number and this number. Those are the first two most important things. And then also probably this number or the next number over here, the R squared or the adjusted R squared. Those are the numbers that my eyes are drawn to, just as somebody who's done this stuff a little bit. Oh, and also this number here. The reason is usually what I'm drawn to is the magnitude of the slope and also the direction. So the sign and the direction on the slope, that's important. And then also the p-values, because those answer the questions, are y and x related? And then also the R squared, because that also answers something about how strong this relationship is. So let's take it part by part. We'll start down here at part 3. And so when we did all the work last class, and then I guess last week too, what we found was that A equals 12 and B equals 0.2. And so Excel calculates those for us very quickly. And those were the numbers I just found when I did it by hand pretty quickly. By the way, these two, the top part here and the ANOVA part, the top two portions, they'll stay the same height. You know, they'll always be, what is that, like 1, 2, 3, 4, 5 cells tall, and then this is 3 cells tall. But this thing extends as far as it needs to, right? This is our first, this is our intercept term, but then you're going to have a slope term for every regressor. And so K is, you're going to have K plus 1 rows. I hope that makes sense, right? Because we have, in this case, K is 1, so we have 1 slope term. But if we had other X's, these would be our X's. It would tell us the name of our X's over here. And you have a different, you're going to have a different slope estimate for each of those. That'll be more relevant when we get to multiple regression. But I just want you to know, if you see a table that has more rows, that just means we have a model with more than one X in it. Okay, so it gives us A and B. It also gives us, one of the things we wanted to calculate last time was a t-statistic, which was B minus 0 divided by S sub B. That's a terrible S. Let me try that again. S sub B. Which, if you want to reduce that, you just get B divided by S sub B for your most typical t-test. And in order to do that, we need B, but we also need S sub B. And that is what they give us in this thing called standard error. Up here, they give us S sub A, which we don't care nearly as much about, but maybe useful sometimes. And then to calculate our t-statistic, we can just take B divided by S sub B. So 0.2 divided by 0.086603, hey, that's equal to 2.309401. And so this is our t-statistic, okay? Now, in order to run that t-test, we need to know how many degrees of freedom we have. It has n minus k minus 1 degrees of freedom, and it's a two-tailed test. And it turns out that that means that we have this p-value if we were to run that test. The degrees of freedom is actually already on the table, right? So there are degrees of freedom on here as well. I'll touch on those in a second. But I did want to draw your attention to the fact that we have a p-value right there where the null hypothesis is that beta equals 0. And so in this case, we can see that the p-value is larger than 0.05. And so we would probably conclude that we would fail to reject the null, so that we can't conclude that it's greater than 0. Over here, we have estimates on alpha and on beta, and these are interval estimates. And it'll always give us these. In this class, we're not going to play with those too much, but sometimes they're useful. I'll say, like, for example, if we're trying to estimate the effectiveness of a particular policy. So let's say I ran an experiment where we're trying to figure out how to get people to reduce their congestion. So people overuse roads, people overuse fisheries. And we want to know, like, what is the decrease in congestion when we, yeah, I like Excel too, Andrew. What is the decrease in congestion when we implement a policy, for example, where we sternly caution people not to do this? Like, every time you consume more than your fair share or whatever of fishes from the fishery, it reduces everybody's payoff. And we want to know what the effect is. In that case, we might use the 95% confidence interval to say, you know, we're not exactly certain what the effect is, but the effect is somewhere between 7.6% and 47.6%. There's something like that, right? So yeah, it depends on the situation, but beta sub 0 is it the same thing as 0? In this case, so Excel always and only runs a t-test where beta is where the null is beta equal to 0. So it is possible for beta sub 0 to take other values. It is not possible. Excel doesn't allow you to test those. Other statistical software, or doing it by hand. You could do it by hand, right? So if you know what your essentially, if you know what your coefficient is and you know what your S sub B is, you can always calculate your own test statistic, right? So it gives you the stuff you would need. But the test that it runs for you just always assumes that beta equals 0 or beta 0 equals 0. Okay, but that's not generally true. Beta 0 can take lots of values, whatever you want it to take. So for example, actually we'll do an example after this. We'll do one of your practice problems after we go through the Excel stuff. And I'll show you a case where you might want to check to see a different value for beta 0, which I think is awesome. I like the example a lot, but we'll talk about that later. So that'll keep you watching till the end. Okay, so that's the part 3 section, right? The main things of use, again, I say, are this the estimated value of B, because that tells you quantitatively what is the point estimate of the relationship between y and x. In this case, a 1 unit increase in y is a 0.2, or in x is a 0.2 unit increase in y. That's what that 0.2 means, right? So if you have so over here, if we expect our percent options to go up by 1, so from 20 to 21 here, we would expect this to go from 10 to 10.2 or whatever. We would expect it to go up by 0.2. Cool. So that's and then the p-value is the test. To test to see whether that's a statistically significant relationship. All right, the one that's easiest to wrap our heads around probably is the ANOVA section. This DF, this column tells us about how many observations we have and how many regressors we have in order for us to have the right number of degrees of freedom for all of our statistical tests. So when I start looking at these, usually I like to give myself a little mnemonic over here. So on this left-hand side over here, I'll usually write like a little R, E, T in the margin. And that'll come in handy for our SSR, SSE, and SST, and our MSR, MSE, and MST. You'll see in a second. Okay. This first DF here, pardon me, squeak. This is our value of K. And I said before, this is the number of X's in our model, the number of regressors. And in particular, here it is the number of rows we have below the intercept. So since we have 1 row below the intercept, K equals 1. If we had more variables, we would have more rows below the intercept. And then K would take on some different value. Okay. Pardon me, the dog is barking because of the mailman, I assume. Let me close my office door. 1 sec. Pardon me. All right, back. Okay. The number of degrees of freedom in the residual is n minus k minus 1, which we've seen before as our number of degrees of freedom. Hold on, let me see if I can write that a little bit more legibly. N minus K minus 1. And so that's 3. In order to finish this thing out, this down here is N minus 1. And then we're going to go sneak up here for a second. This number of observations is N. So these 4 numbers are linked together. Right? We've got 5. We lose a degree of freedom when we estimate. We get 4. We've got 1 in the regression and 3 in the residual or in the error. And the logic of this table, when you play with it a little bit, it's very satisfying. It's very crowded, but it's very satisfying because the numbers all connect to each other logically based on their physical location. So if you add these two together, you'll always get the bottom one. 1 plus 3 is 4. K plus N minus K minus 1 equals N minus 1. Cool. Okay. The next thing that Excel shows us is the sum of squares column. And so this first one is the SSR. SSR. Cool. The next one is the SSE from over there. And again, if we add these together, they give us the last one, which is the SST. Thank you, Andrew, for the tech support. SST. Okay, and so those are useful, right? Excel gives those to us. That's handy. Those are things we might care about. The next ones that we have here are the MSR. So this is the MSR. I have a little room here, so I might as well make use of it. And if you remember, the MSR was the SSR divided by K. Hey, those two numbers are right here. So we take this SSR, we divide it by K. I mean, it's dividing backwards, but that's how we get this 160. And then this one here is the MSE, which, if you recall, the MSE was the SSE divided by N minus K minus 1. Okay? And so, again, those numbers are here. You can't see this 3 that was here. There's a 3 here. But we take this 90 divided by this 3, and that's where this 30 comes from. Cool. So those are all calculated in there. They should match the work we've been doing in class. Our F statistic, F is equal to the MSR divided by the MSE. That's this right here. And that's where that 5.333 comes from. And then this right here, this is the p-value on a t-test. Microsoft Office button. It might be file. It might be an Office button in the upper left-hand corner, depending on your version of Excel. But it should be a button in the upper left-hand corner. Depends on the version you have. So this is the p-value from the F test. So if you needed to find this value, for example, because the way that I'll test you guys on this is I'll give you kind of a table with blanks in it, and you'll have to fill it. I'll give you enough information to get started, and then you have to work your way through. No apologies necessary, Brad. Computers are tricky. We'll learn. P-value F test. And if you remember, F has K degrees of freedom in the numerator and N minus K minus 1 degrees of freedom in the denominator. And so if we want to see where that 0.104 came from, we could check our numbers, right? So we've got equals F this to RT because it's a right tail test. And then our 5.33333. And then over there, we had 1 degree of freedom in the numerator. That was in the DF column right over here. That's 1. And then our 3, which I've written over multiple times now, it goes in the denominator. And you can see that's where that 1.0 or 0.104088 comes from. So that's an F test. So that's the ANOVA section. We've got our degrees of freedom. 1 and 3 add up to 4, which is N minus 1. We've got our SSR, SSE, and SST. We've got our MSR and our MSE. We've got our F, and then it works its way logically over to our p-value. Cool? All right. It's a very busy table. Hey, Brad, it might be worth holding off and figuring that out at a different time. I don't know. I guess you can always watch this later. But yeah, stat plus LE, you need to download it from online. Thanks for sharing that, Willie. All right, let's finish the top part here. Up here we have R squared. We've seen that before. That's going to be our SSR divided by our SST. And those are down here, right? So that's 160 divided by 250. That's where that 0.64 came from. The multiple R, that's our RXY, except it's actually the absolute value of that. So this will be always positive. The multiple R will always be positive. And so it's just the square root of our R squared. You'd have to go down and get the sign from B to figure out what the correlation coefficient is. But this is the magnitude of the correlation coefficient is the multiple R here. Adjusted R squared, we're going to wave our hands at that. We'll come back to that after the exam. It's a little tricky, but not worth spending time on just yet before the exam. We'll cover it after the exam. And then the last thing on the table, this standard error. This thing is S, which we learned last class is the square root of the MSE. Cool. So there's a lot here, right? And I'll say, like, it is a very dense table. And that is not by accident, right? Because you'll notice when we were doing these problems, we spent a lot of time finding each of these things. And so there's a lot of information that we might want to know. And Excel's regression output does a pretty good job of presenting all of this information to us in a readily digestible method. Doesn't take up a lot of space, covers a lot of material. And it takes a little while to get the hang of it, but once you kind of understand how it's laid out, it is very logical. It makes sense, right? So each thing is next to something that is useful. So we'll play with it a little bit. Not only, well, right now we're going to do a practice problem, and then we'll run it in Excel. And then after the break, after the exam, I'm sorry, we'll be dealing with multiple regression, and that shifts gears a little bit, right? Because we're going to take the weight off of us to do the arithmetical calculations, and we're going to lean on Excel to do that. And instead, we're going to move more toward interpretation, right? And so, for example, I mentioned it a little bit earlier, but when we do something like y hat equals 12 plus 0.2x, and then we get a p-value, and then we have a list of p-values, and we see that the p-value equals 0.104 or 088, like a lot more important is going to be, can we run the test that got us this, right? So what test does this come from? Do we know what the hypotheses are, right? And we'll still have to state those hypotheses, and then we'll want to draw a conclusion. So if we fail to reject the null, what does that tell us? We will not have to use Excel for the exam. This is both for people doing this part of the project, but also going forward for the rest of the semester, we will be doing all of our regression stuff in Excel. Now, when I say doing all our regression stuff, a lot of times what it means is, since you could see how quickly doing it in Excel is, doing it in Excel means like clicking 3 buttons and then it goes boom. And so what we'll do is we'll spend a lot of time with a table that looks like, well, it won't have all this ink on it. So it'll look instead like this. And then we'll say, okay, well, I see this table. Okay, tell me what it means, right? Tell me what a company should do, or tell me what this implies about the way the world works. Right? And so that's where we'll go. Is this a good model? Should we get a better model? Is there a problem with this model? Is it nonlinear? Is there, or should we have a quadratic term? Or is there a problem because we're comparing apples to oranges? And we'll be able to suss that out from tables like this. And so we'll spend some time. We'll also spend a lot of time just thinking about things like, what does alpha mean? What does beta mean? And what is the interpretation on beta, depending on what x and y are. To kind of prepare you for that, to shift to gears to the interpretation stuff, I want to work through a problem with you guys. It's one of your problem set problems. Let's see, where is it? Quant, class problems. Problem set 9. That's one you guys are working on, right? And it's number 21, which some of you have already done, certainly, but some of you have not yet done, I'm sure. And so this is what we're going to work on. All right. So, Jinkies. I missed the Jinkies part. Yeah, yeah, it's going to be a little tricky, but it's good. This is when like real math is. A lot of people think of math as the number stuff, but real math is the thinking stuff. We're going to look at cost estimation. You can read it all together. An important application of regression analysis in accounting is in the estimation of cost. By collecting data on volume and cost and using the least squares method to develop an estimated regression equation relating volume and cost, an accountant can estimate the cost associated with a particular manufacturing volume. Consider the following sample of production volumes and total cost data for a manufacturing operation. And then there's some data there. And then it says, use these data to develop an estimated regression equation that could be used to predict the total cost for a given production volume. So this is the data that I have. And now we need to make sense of this. So let's go back to Excel. I don't want it there. I want it here. I'm going to create a new tab. I'm just going to drop the data in. And actually, can I paste special Unicode text? There we go. Because I don't actually want all the fancy formatting. By the way I did that, I pressed Alt-E, S, oh, not Alt-E-A, Alt-E, E. Apparently I'm doing it wrong. Okay, I'm doing a terrible job. How do I do it? Control-C, Alt-E-S. There you go, Alt-E-S, and then I pressed V for values. So Alt-E-S brings you to paste special. Pasting special values is something I do very frequently. Or I guess in that case, I did Alt-E-S-U. I don't know, something's going haywire. In any case, this is my data. So I've got my volume and I've got my cost. And the question now is, how do we build a model, right? Well, it tells us here, we want to predict the total cost for a given production volume. So if I want to predict the total cost, my predicted is going to be my hat. And so that tells me that my total cost is going to be my Y. And so if I'm going to draw myself a model, it's going to look like this. How do I know it's going to look like this? Well, because they want me to use a regression equation, and I only have one X variable. So I know that this is what my model is going to look like. But instead of just a very generic formula, what I'm going to do is I'm going to rewrite it in a little bit more specific fashion. I'm going to say, cost equals alpha plus beta times volume plus epsilon. Now, why do I love this example so much? Well, I love this example because we teach this example in Principles of Microeconomics. It didn't look like this, but I want you guys to try to think about this, okay? So let's say instead of cost, let's call this total cost, because that's what it is. Well, that's going to equal something plus something times quantity. We'll treat it as though it's a deterministic relationship because that's how we treated it in Principles of Micro. But I want you guys to think about the two types of total cost, or two parts of total cost. So in Principles of Micro, what were the two parts of total cost? What made up total cost? Okay. And while you guys are thinking about that, I'm gonna start doing this example. But what's more important to me in this case, because you guys are already getting close to mastering the interpretation or the technical stuff. What's more important to me in this case is that you guys understand the interpretation. So think about what goes into total cost in microeconomic analysis or in accounting, right? You guys do cost accounting. I think that's managerial econ. So you guys think about that. Meanwhile, I'm going to set this up as a hand done problem, and then we're going to do it in Excel both ways. Cool. So 400, 450, 550, 600, 700, 750. And then cost. Volume is my X. Cost is my Y. Fixed cost, that's right. So good job, Samantha. One of them is fixed cost. What's the other one? Variable cost, that's right. So we've got variable cost. Okay, so what's the difference between fixed costs and variable costs? $5,400. 5,900, 6,400, and 7,000. Still got to remember it, Cooper. Total cost is total fixed cost plus total variable cost. That's right. So now let's call this part 1 and part 2. Which of them is total fixed cost and which of them is total variable cost? You guys tell me which is which. In the meantime, we're going to keep working this problem. In order to calculate our slope and our intercept term, we're going to need to get our x bar and our y bar. Fixed cost doesn't change. Doesn't change with what? In the long run, it changes, right? 0, 5, 10, 15, carry the 1. Variable cost depend on quantity. That's right. So one of these is going to be the variable cost. 8, 9, 14, 20, 34. 3450 divided by 1, 2, 3, 4, 5, 6. 3450 divided by 6. That's going to be my x bar. I don't know which one that is. 3450 divided by 6. Should we do this by hand? That's going to be 500 plus whatever 450 divided by 6 is, which 6 goes into 45 7 times. 575, I think. Should we double check that? So we can use equals average here. Check our math. 575, cool. So we got our x bar. Yep. So that's right. So let's do y bar and then we'll go back to the equation before we figure out the slope again. We got y, this adds up to 0, this adds up to 0. 9 and 4 is 13 and 4 is 17. Carry the 1. 1 and 5, 10, 15, 20. Plus 13 is 33. 33, 700 divided by 6. Nice job, Andrew. Y bar divided by 6, that's going to be 5,000. 1 is fixed cost. Nice work, Sophia. That's correct. 5,000, 37. That's going to be 600. And then we've got 100 more to spread over. 10 divided by 6 is 1. Is that right? Yeah, with 40. 40 divided by 6 is, what is 40 divided by 6? 5616.6, I think is right. Let's check that. All right, that's 6 bar, right? So, yep. Cool. Okay. So now we've got our y bar and our x bar. Cool. Yep, Andrew got that too. Okay, we got our y bar and x bar. We're going to play with those to get our slope in a second. But first, I want to go back up to here. That's right. So you guys, I think people came to the correct conclusion. This is going to be our fixed costs plus our variable costs. But now I need to divide that in order to figure out what this thing is here, right? You rounded a little off there at the end for each because it has to be a 7 somewhere. There you go, Willie. This has to be, in order to figure out what this is, we need to know what do we multiply by Q to get our variable cost. Well, it turns out that to get a variable cost, we're going to have to take something times Q. Well, that would be variable cost divided by Q, right? Because variable cost divided by Q times Q, the Q's are going to cancel, and that'll give us our variable cost. And so this term right here, we've decided is fixed costs. This term here is variable cost divided by Q. We have another name for variable cost divided by Q. Again, from micro. So you guys tell me what variable cost divided by Q is, and then we'll know a little bit more about how to interpret these things. In the meantime, we'll keep working the problem. Okay, so in order to get our estimated value of B, let's go down here so we can write the equation. Our estimated value of B, we learned this a little while ago. This should definitely make its way into your formula sheet. That's going to be the deviation from the mean in X, which is xi minus x bar, times the deviation from the mean in Y, multiplied together for each observation and then summed. And that's our numerator. Then once we have that, we need to divide that by the sum of the squared deviations in x's. Are you in the right place? Louisa? You're in the wrong class, Louisa. Stat will be posted soon. Okay. Da-da-da. So let's calculate B. Well, we might as well write A down here while we're at it. A equals y bar minus b x bar. Okay, so let's take a look. We need xi minus x bar and y minus y bar next, so let's do that. Xi minus x bar is a little bit easier. In each case, we're subtracting 575, right? So 400 minus 575 is negative 175. 450 minus 575 is negative 125. 550 minus 575 is negative 25. 600 minus 575 is positive 25. 700 minus 575 is positive 125. And 750 minus 175 is positive 175. Okay. So those are our xi's minus our x bars. I'm not super confident in that, so I'm going to do them over here as well, just to double check my math. I'm going to make that an absolute reference with respect to the row, but relative with respect to the column, so I'll be able to use it for my next column as well, for my AYs. Sure enough, those are correct. Okay. Got lucky. Next, we'll do yi minus y bar. Still waiting on you guys to tell me what VC over Q is, by the way. So if you get that, let me know, and we'll go back to that when we move things along a little bit. Okay, in this case, 4,000, I'm subtracting 5616. I'll just call that 56. So we call that 5620, just to make the subtraction easier. Let's call it 5620 or 5620. That's 3 significant digits. So 4,000 minus 5620 is negative 1620. 5,000 minus 5620 is negative 620. 5,400 minus 5620 is negative 220. 5,900 minus 5620 is positive 220, I think. Trying to do this in my head is tricky. 6,400 minus 5620. Well, 64 minus 56 is 8. We need to subtract 20. Oh, no, that last one's going to be 280, I think. Yeah, 6,400 minus 5620. 64 minus 56 is 8. 800 minus 20 is 780. ABC, Cooper. Yeah. Rakira, nice. Yeah, so we're going to average variable costs. We'll talk about that in a second. And then 7,000 minus 5620. Well, 7,000 minus 5,600 is 1,400. I just rounded this number for Reed. Just because I'm trying to do it in my, so if you want to see where that comes from, let's say I did, round this to 3 digits. Does that work? Oh, negative 3. Oh. There you go. That's where the 5620 comes from. I rounded it. It's 5617, Samantha, if you want to round it to the nearest unit. But if you want to round it to the nearest 10 because you find subtraction hard like I do, then it's then it looks like this. Okay, so I rounded. And that's going to be a little bit off. Let's see what it should be exactly to see if I was close. 1620, 620, 220, 280, 780, 1380. Yeah, I'm okay with that. We were pretty close. Yeah, so that's the, just to be clear, these are xi minus x bar, yi minus y bar. And for what it's worth, I'm totally okay with you rounding a little bit extra on an exam in an environment. I wouldn't show you how to do this if I wasn't comfortable with that. But rounding a little bit makes the math a little bit easier. Obviously, you got to round somewhere, right? Because if we actually extend these, I mean, if I actually just make this wider, like this, you should not be doing this on an exam. I don't need to see 3, 3, 3, 3, 3, 3, 3, 3, 3, right? You've got to round it somewhere. Why round it to the nearest unit? It's an arbitrary decision made by whoever decided that like the dollar would be the thing that ended before the decimal and that cents would be after that. It doesn't actually make that much sense per se. Like it's not a deeply embedded human truth that we should round at the unit. It's just kind of where we decide generally to do so. In this case, I'm rounding to the nearest 10. Okay, to continue this, we need to take this column times this column. And I really need a calculator for this. So actually, at this point, I think I'm going to switch over to Excel to get the exact answers because it's not worth the time to try to do it by hand and screw it up. The calculator I'm using right now is Excel, so might as well use it since it is powerful. So to get my numerator, I need to multiply these together. Negative 175. Oh, the one thing I want to draw your attention to right now is that the numerator is going to be the product of these, right? And you can see that this times this is a negative number times a negative number, which gives us a positive number. And that is true in every case in this case, right? And we didn't look at a scatter plot. It might be useful to look at a scatter plot. But you can see that all of these numerator, the things we're going to sum for the numerator, they're all positive. It's not surprising. As you produce more stuff, you should expect it to become more costly. Is this my scatter plot? No, that's my 2D line. This is my scatter plot. And so if I want to see the scatter plot, change chart type. No. This is what happens when you try to do it in a little tiny thing here. In any case, you can see that what we have here is a positive relationship. Not perfectly linear, but pretty obviously positive. Cool. And that positivity is a result of the fact that when costs are lower, or when volumes are lower than average, costs are lower than average. When volumes are higher than average, costs are higher than average. So that's where that positive relationship is embedded. Looking back over here at our formula, what we have here is the terms for the numerator. Okay, that's this stuff down here. These right here are 6 different products. And this thing here tells me that what I have to do next is to sum them. So to sum them in Excel, very straightforward, equals sum. And then I just add these all together. And that's my numerator, right? So this would be my B numerator. And if I want to keep track of that, let's write that over here. 712,500. And my B denominator, well, to get that, I need to square my xi's minus my x bars. So let's do our xi minus x bar, the quantity squared. And here's where I'm just taking these negative 175, negative 125, all these ones and squaring them. And so if I sum these, I'll get my denominator, which is 93,750. And to get B, I just need to divide these. So B is now 712,500 divided by 93,750, or 7.6. Okay. Now, I feel like we're in the weeds a little bit. We're going to stay in the weeds a little bit longer to get A, and then we're going to pull back to the estimated regression equation, and then we're going to pull back to how we think about the world. So let's finish the technical stuff, and then we'll go back to the discussion we were having earlier about the AVC and the fixed cost, okay? So to get A, we need our Y bar, which we calculated right here, 5616.66 continuing, minus 7.6 times 575. So to do that over in Excel, we take advantage of the fact that I already calculated these right here. So my A is going to be equals 5616 minus 7.6 times x bar. And there we can see it's 1246.667. Okay. Now, if I'm rounding, obviously these numbers are going to be different. I hope that's clear. So what will happen to them, we can see, because I did this all with formulas. If I just type 5620 here, you can see that it changes things a little bit. Not a lot, though, right? So by rounding, by choosing a rounding value there, I get a slightly different estimate of A, but my B is totally the same. And so rounding a little bit here and there are not going to make a huge difference. Just to show you again, you can see that if you calculate this in Excel with formulas, you can see what happens. Oh, that's wrong. 5620 instead of 5616.66666 just changes A a little bit. Not a big difference. Cool. I hope that's a useful demonstration. Okay, let's talk about the intuition here a little bit. First, let's write ourselves our model again. Okay, our model was y equals alpha plus beta x plus epsilon, or cost equals alpha plus beta times volume plus epsilon. And that is our model. That is from where we derive our estimated regression equation. I'm going to stick with just the definitive forms here. The estimated cost given volume, meaning, or the expected cost given volume, not meaning the average cost, but the average conditional cost, knowing the volume, is alpha plus beta times volume. Thank you. And this is our regression equation, is what we call this. And that is the line that we talk about in theory, right? That is the line we talk about in theory, our cost estimation, our total cost. And then our estimated cost using data, our sample cost, well, that's equal to A plus B times volume. But we said that cost and volume are just other ways of saying total cost. Well, we can write this while we have the data right here. Cost hat equals 1246.6 plus 7.6 times volume. Or to rewrite it, we can write cost, total cost, estimated, TC hat equals 1246.6 plus 7.6 times Q. And now we can estimate an average variable cost, right? This implies that our AVC, which is variable cost divided by quantity, equals 7.6 times Q divided by quantity equals 7.6. So our average variable cost is 7.6. Now that is a very important number, right? Because in studying production, we learned that you should shut down if your price falls below your minimum average variable cost. And so knowing what our average variable cost is pretty useful, right? And so what we could do now is we could do statistical tests to see, is this, this is an example of where you might care about beta 0. Is it, let's say our minimum average variable cost, or let's say our price was $6. We could test statistically to see whether this estimated value is statistically significantly different from 6, right? But in addition to that, we also could calculate our average fixed cost, right? Our average fixed cost is going to be 1246.6 divided by Q. And so that will vary with quantity, but we can calculate it. And we can also use that to calculate our average total cost. Our average total cost is going to be 1246.6 divided by Q plus 7.6, because that's our AFC plus our AVC. Cool. And now we can have a whole cost curve that we have estimated. This ATC, average total cost, is also known as unit cost. So we could calculate our unit cost curve. Now this assumes that our average variable cost is fixed, right? Whether that continues or not will vary with marginal cost. But in a constant marginal cost industry, this would be your average. This would be an estimated average total cost curve, which is cool, right? This is a neat example. Cost estimation is really useful, and regression. In this case, we only have 6 data points, but regression is a useful way to get at it. All right, now let's do this with Excel's regression tool pack, so we can see how we did. So again, we click regression. I need to replace these. My Y is now starting in B and goes down to here. Those are the companies that I have. My X's are right here, my volume in units. I still want labels, but now I'm going to call this TC equals volume for total cost. I click OK. Then here I have my my output. Once again, the things I look at first are down here. I can see my estimated average variable cost is 760. And then I look at my p-values. It's definitely not 0, right? That's what this p-value is telling me, because the beta here is that it's equal to 0. And also this regression seems to have some relationship, which is really comforting to know. What this tells us is that cost and the amount of stuff you make are related, as well they should be. And in fact, this R squared here tells us they're pretty closely related, right? So 96% of the variation in my total cost can be explained just by how much stuff I made. And that's comforting. We'd like to know that making more stuff is the primary determinant of how costly things are. But one of the cool things is that we also could take this and use it to calculate a t-test against a different beta zero, right? So if my beta zero instead of 0 was $6, then what I could do is take 760 minus $6, and this would be my t numerator. And then I want to divide that by S sub b, which is the 0.7881 here. So that's still my S sub b. And so I can take 1.6 divided by 0.788. Now I can do a two-tailed t-test if I want to see whether this, with n minus k minus 1 degrees of freedom, is statistically different from $6. And I would have to say, no, it's not statistically significantly different from $6 or something like that, right? That could be useful information. But one of the nice things about doing it in Excel is now I can change this to other values and I can keep running tests, right? Significant. Oh, I see. That's because it's negative. So let's do the absolute value here. It gives me an error if I put a negative number in here. So if I want, I can instead put in the absolute value of D20. Now I can change this to whatever I want. 760, 8, $5. It's definitely not equal to $5, or almost certainly not equal to $5. 550, 545, whatever. You plug in different stuff, and you could run a bunch of tests. Figure out what you can conclude and what you can't conclude. Cool. Okay, I really like this example because I think it does a good job of showing a specific and useful application of regression analysis for cost estimation. What I'd like you guys to be able to do is be able to calculate this to get predicted costs. This tells us how to compute the coefficient of determination. We talked about that briefly. Oh, to estimate the 500 units must be produced next month, the estimated total cost for this operation. Well, since we have, I'll go back to here. Our total cost for 500 units would be A, 1246 plus our variable cost times the number of units. So if you want to see the formula for that, here it is. But you could do this by hand, right? It's just 1246.667 times 7.6 times 500. And it turns out that's our estimated cost. Cool? I don't know. I think it's pretty cool. Hopefully you guys think it's cool. But that should just about do it. That's the stuff that I expect to be on the exam, everything up to here. So if that sounds okay with you guys, we'll leave it there. We have a few more minutes in class. If you have questions, you want to post questions, feel free to drop them in. I'll be sticking around for another 6 or 7 minutes. And then I need to skedaddle off to my next class. So hopefully you guys found it useful. Again, as always, leave feedback on Slack, send me emails, and don't forget to get your stuff in when it's due. Let me see, put this back up so you guys can see due dates. Thank you. Where'd you all go? Oh, there you are. Thanks, Lubuff. Hopefully you found it useful. Andrew? Oh, Jordan, you joined us. I'm trying to interpret names. The exam will cover everything, actually. So it is. If you look at the practice exam, it's comprehensive. Obviously, I'm not gonna lean as heavily on the first stuff as I am on newer stuff. So more heavily on the newer stuff. But you still have to know how to figure out stuff in a normal distribution. An equation sheet again, Jordan. Yeah, formula sheet, 1 page, front and back. That's it, though, right? So you can either use yours, and this is exclusive. You can either use yours or use mine. You should make that choice now. I dislike forcing people to make that choice on the day of the exam, but I'm totally willing to do it. Am I going to be supplying your own as well? Either way. The formula sheet that I make for you is posted on D2L, so you can take a look at that, William. But you have to decide ahead of time. You're very welcome, John. You have to decide ahead of time which one you would like to use. Cumulative exam. Yes, I view all of life as cumulative, and everything is fundamentally interrelated. So addition, subtraction, multiplication, division, exponents, some algebra, curves, graph of a line, anything else you learn in 7th grade math, anything you learn in 8th grade math, anything you learn in 9th grade math. I'll try to keep the trig to a minimum. But anything we've learned in this class certainly is fair game. Cool. Thanks, John. Thanks, Mohammed. Hope it was useful. Again, remember, the video will be available posted here, so you should be able to take a look on this URL after the fact to be able to see it when it's ready. Cool. Thank you guys very much. I'm sorry for a few of the hiccups early on. Hopefully it worked out and you're able to see everything. Any other questions people have for me? Another couple minutes before I need to bail on y'all. Okay, if that's it, you guys are free to go. So you guys can head out if you're done. Thank you very much for your participation. Hopefully you found it interesting and useful. The video, is this video available on D2L? Yeah, there's a link in the news page, but yeah, the video will be up on my YouTube page once it's done processing. So once we say goodbye and I click end broadcast, it takes a little bit to compress, but once it's compressed, it should be readily available for everybody to watch. I'm going to edit it just a little bit, I think. But yeah, it should be up there. You're welcome, Sophia. Thanks for coming. And again, I'm sorry that we don't have access to the A building. We will soon enough, I'm sure. But hopefully you guys found this a useful temporary fill-in. I don't know, Samantha. Actually, the best way to ask me about that is to ask me over email. I'll try to make a note of it, but if you email me, Samantha, then it'll be on my to-do list to check your grade. I know it's a little weird how I work in terms of what type of message will get through to me. I don't know if it was or not off the top of my head, and because I have to go teach another class right now is not a good time to check. But if you email me, then when I sit down to process my email, that'll be one of the things I do. Anything that takes less than 2 minutes to do when I get an email, I just try to do it right away. So if you send me an email, that's a good way to get through to me on that. Cool. Ooh. Somebody else had a question. Okay, cool. Thanks, Samantha. Perfect. Anything else? Oh. All right, I think that's it. Thanks, everybody. And yeah, this should be up soon. Thanks a lot, guys. Bye.